trouble finding the modulus of u? Any questions or comments or concerns about that? So 36 plus 9 square root of 45? Are we feeling okay? Yeah? Okay, all right. And so where is it located if I was to draw this thing? Over 6, down 3, down there, right? So does anybody want to, in words, describe how you go about finding the argument? You have this guy here. We're trying to find that angle. So what's the easiest way to do it? Find this angle that's comparable and do what to that answer? Just negate it, right? Okay. So did anybody have any trouble finding that? Tan alpha is equal to y over is equal to y over x. And what are you getting when you are solving for this? Nobody dares?
I got negative 0.464.
Negative 0.464. So this would be negative 0.464. And so what are we going to do with that? Well, we know that that's the exact answer we were looking for. You didn't get that? Well, you should get positive with this and then you negate your answer. So remember, tan of theta equals y over x. So
I didn't change it, that's why.
this is y.
I know I did. I didn't change it from degree.
Oh yeah, you need to be in the rating.
I told myself to do that.
Okay, are we cool with that? Yes, yes. You may. So, questions, comments, concerns, issues? Yes, no, maybe? We're good? Okay. Could you do the same thing for W for me? Yeah.
Would it be wrong if we just did the one that they want to see us use alpha? Like if we just plug it in as the negative 3. So,
Does it come up with the same answer?
yeah, like it comes up with the negative 4.
Okay, just be careful.
Then
Yeah.
if we do it that way, then there's no issue.
I don't think it works, yes, but it doesn't work in the other quadrant, so you just have to kind of be careful. That's all. Okay.
Yeah.
Leave a little space under this for a minute, please. We're gonna come right back to it. But I'd like you to try W, if you don't mind. How is W going? -7. Okay. Is anybody able to find the modulus for W? The square root of what, 49 and 25? Thank you. Square root of 74. It's not cleanable. I don't know if that's a word, but we really could leave it like that. And then how do we go about finding the argument of it? So it's pi minus the alpha we find. And in this case, it is the y divided by the x. Okay, and what are we getting when we do the y divided by x? Anybody have anyone they want to share?
Negative 0.6202.
What is it? Oh, this is 0.6, so pi minus 0.6202, you said? I think that's what I hear. 2 0.
She has it. She has
I
it.
got it. Woo! Okay, so go ahead and do pi minus that. What do you get? 2.5213 basically, right? Okay, now, everybody agree we found modulus argument, modulus argument? Okay, what we have is our normal form that we've been working with, the complex number form, x plus iy. There's another form, and it's called the modulus argument form. Okay, so occasionally they're going to say, hey, given this, we want you to put it in the modulus argument form. Step 1 of getting into the modulus argument form is to find the modulus, and define the argument, which is what we've been doing, right? So the last part of this step is to use this little formula. Write it out for you. It is z is equal to, z is equal to r times cosine of theta plus I sine of theta. So, R is the modulus, and then theta is the argument we've been finding. Does that make sense?
That makes, yes.
Okay. So, in this case, what is, let's do the first guy, from this form, okay, from complex form to modulus argument form. Okay, it's going to be u equals, because it's a u, not a z. And what's r in this case?
Radius? No. I wish.
Square, it's 40, square root of 45, right? Can that be cleaned up at all? Yeah, because it's, oh gosh, this is so dirty. Do you see my handprint? How? Yeah, we can make it 3 root 5 if we want to make it pretty. So 3 root 5, and then we have cosine of, and what is my theta in this particular case? My ending zone is negative 0.464, and then plus I sine of negative 0.464. That is a modulus argument form. Could you put the next guy, W, into the modulus argument form, please? This one's going to be the modulus argument form of W. So it's going to be W is equal to what? Square root of 74
times cosine of 2.5213
plus.
plus I sin sine of 2.5216.
Exactly right. Literally, it's just plugging it in. So oftentimes, you're going to get major points for finding a modulus, finding an argument, and then putting it in modulus argument form, which is not a bad deal. There's one more form. It's called the exponential form. So we've got complex form, modulus argument form. All right. Euler. Anybody cares? It's called the Euler form, but we also call it the exponential form. Okay, and the exponential form is z is equal to r e to the I theta. Okay, r, just like before, is the modulus, and theta is the arg of that formula. So if I was asking you to put u from complex, and you have now modulus argument, could you now make u into exponential? What is r in that first case scenario? Square root of 45, right, or 3 square root of 5. E to the I, and what is the theta in that case? And that is exponential form. It's really ugly. But Euler,
Make us do anything with it, or just put it in the forms?
eventually we may, not much. Could you take W and make it into exponential form? Please.
Is it just in this?
This is the one we just got done working with. R's R, and then e to the I theta is the same thing as cosine plus I sine theta. They're equivalent. There's a whole proof that goes into it.
Okay, how did they have the time to find out that this?
Euler discovered this. He was, well, interesting enough, I'm glad you asked. So Euler he was born in 1707 and he died in 1783. So somewhere in the 1700s, he discovered that to go from the modulus argument form to the exponential form. I think that's kind of, whatever, that's crazy. Like, who has that kind of time? You're right, but in 1700, what else did you do? I don't know. Forage and eat and. You gotta get food somehow. Hunter gatherers, I don't know. That's really funny. Okay, guys, so we have exponential form, modulus argument form, and then they oftentimes refer this to complex or the Cartesian form. So they go back and forth. You can liken it to an x and a y. You know what I mean? Like it has an x and a y. So occasionally they're going to give you problems and they're going to say, write it in the modulus argument form, write it in the exponential form. So I am going to actually give you that right now and then I'll be done for the day. I don't know, did they forage in the 1700s? I don't know, what did you do in the 1700s?
Farms?
What?
You probably farmed.
You farmed.
Not an agriculture.
No hunter-gatherer, no?
Domesticated wolves.
They domesticated wolves, which now I lovingly keep in my home. Okay. One plus I. I want you to go to the modulus argument form and then the exponential form for this guy. Okay.
Hardwood, tell it.
She's actually wrong.
It's like it's taken off. We are, we're something. Building fences. We can, no, you may.